This is understanding mathematics, as we have already elaborated earlier on. Today we are starting a very important topic which is difficult to most pupils. We are calling it transformation. Hey guys, you need to understand this. Transformation always comes in paper 2, 12 marks in section B. Whether you like it or not, you face a question on transformation. But also in paper 1, they may bring 3 marks, 4 marks, 5 marks, depending on the exam preparation. So we are going to start first of all by defining what transformation is. To transform simply means to change. So I'll define to say transformation is a geometrical, because it deals with geometries. So I'm saying it's a geometrical operation. It's a geometrical operation which involves number 1, change of position, number 1. Number 2, which also involves change of size, and then lastly, change of shape. So you need to remember these are the 3 critical happenings during transformation: change of position, change of size, and change of shape. Now you need to remember the object, the figure we are transforming. The figure we are transforming is called the object. So what you are transforming is called the object. And what the result you get after transforming the object is what we call the image. So we are saying the result we get after transforming the object is called the image. So you need to remember this. We transform the object, the result we get is called the image. Now, we need to understand the types of transformation that we have. Types of transformation. Types of transformation. Mathematically, there are 6 types of transformation. There are 6 types. There are 6 types of transformation. That is mathematically. We've got 6 types of transformation. And once you understand these types of transformation, it means you can't fail any question on transformation. So, number 1, we've got what is called translation. Translation, sometimes it is called vector transformation. Number 2, we've got reflection. Number 3, we've got rotation. And number 4, we've got what is called enlargement. Number 4, we've got enlargement. Then number 5, we've got what is called shear. And then number 6, we've got what is called stretch. So these are the 6 types of transformation you need to know. Now, note, NB means not this, means very, very important. So remember, translation, reflection, and rotation. Translation, reflection and rotation are called isometric transformation. So don't forget that translation, reflection, and rotation are called isometric transformation. Why? Because there is no change. There is no change in shape and size of an object. An object after transformation. So please note that statement, very important. So we are saying that translation, reflection, rotation are called isometrics or isometries because there is no change in the shape and size of an object. For example, if I take this duster, I change it from here to that position. I have transformed the position, but the shape and the size of the duster still remain the same. So such kind of transformation can be translation, reflection, and rotation. Then now, in future, we'll be now explaining to you how can you discover it's a translation, it's a rotation, it's a reflection. Each one of them has got a way of identifying them. That's the first point to note. Second point to note is this: shear, stretch, and enlargement. Are called obliques. So they are called obliques transformation. They are called obliques transformation. Why are they called obliques transformation? Because there is the change in the shape and the size of an object after transformation. So whenever you transform the object, the shape changes or the size changes. It means it can either be these three obliques: stretch, shear, or enlargement. So we're saying because there is a change. There is a change in shape and size. Because there is a change in shape and the size of an object after transformation. In shape and size of an object after transforming or after transformation. So whenever the change of the shape, and the size of an object is happening, it means you're dealing with the obliques transformation. So today we are going to start with the first part of transformation called translation. So we are starting with translation. Translation. First of all, it's important to understand the definition of translation. To translate simply means to change the position. For example, if I take this duster from this point to that point, I've just translated it. Why? I've just changed the position. So translation is the change of the position of an object along a straight line. So we are saying this is the change. This is the change of position. The change of position of an object. But remember, it has to be along a straight line. Along a straight line. So I'll say e.g. Let us imagine we've got the x or y plane. This is the y axis and this is the x axis. and we assume to say, let's imagine here it's 4, and let's imagine here it's 7 on the x-axis. And we imagine also on the y, here it's 2, and there it's 5. And then we call this point, which is 4, 2 as the object. Then here is the image, which is 7, 5. So it means this object has been translated from there to produce that image along a straight line. Right? Now, if you join these points here, if you join this, they'll form something like a triangle. So you can see this is the change in x, which is 7 minus 4, which gives us 3. This is the change in y, which is 5 minus 2, which also gives us 3. So the change in x and the change in y is called the translation matrix. Meaning, you cannot translate this object to that image without the translation matrix. So we can say, therefore, the change in x and change in y as a vector xy is needed to translate any object. And remember, 3, 3 is a translation matrix. So, therefore, this implies that translation can be calculated, the translation matrix can be calculated image minus object. Image minus object. So symbolically, translation matrix equals to image minus object. So given the image and the object, you are able to calculate the translation matrix. So we can say, example, point P 4,7 is mapped onto point K 2,5 by the translation. Find the vector. Example 1. Point P 4,7 is mapped. So the one which is being mapped is the object, so solution. So the one which so the object is point P 4,7 because it is the one being mapped. When they say onto, that is the image, onto point K. So the image is point K, which is 2,5. That is the image. Now they are saying by the translation, so automatically I've told you, you are dealing with translation matrix. Now they are saying find the vector. If they say find the vector, it means find the translation matrix. So the translation matrix, I don't know. Then you need to know now the formula. Translation equals to image minus object. So the translation matrix, you go to the image, write it in the format of a vector, minus the object, write it in the format of a vector also. Then translation equals to 2 minus 4 is -2, 5 minus 7 is -2. So this is the translation matrix of the vector. Now NB. Translation matrix is always written as vector. It's always written as vector, while object and image, is written as coordinate. So don't forget that, guys. Always, whenever you calculate your object and your image, try to convert it in a coordinate form as x, y. But whenever you calculate your translation, it must be in a vector form as AB or XY. Always. That's why our answer to remain the way it is, because we're calculating the translation matrix. So example 2. So we are going now on case number 2. Case number 2, it's given image and, or let me say, given object and translation matrix. How to find image. So that is the second scenario. So we can say example number 2. Point A, -2, -3 is mapped onto point B by the translation matrix. -7, 1. Find the point B, or they can say find the coordinate of B. It's the same thing. So solution, follow me carefully. Always mathematics analyze. Point A, -2, -3. So which means is mapped. That's the object. So my object is point A, -2, -3, is being mapped onto. So let's see, the image I don't know. My image is B. I don't know. I'll call it x, y because I don't know. And the translation matrix T has been given as -7, 1. Find the point B, which means they want the image, which we don't know. So just swap the formula. Image equals to translation plus object. Image equals to translation plus object. So the image, which is B, will be equal to translation is -7, 1 plus the object -2, -3. So the image B will be -7 plus -2, -9, 1 plus -3, -2. If you leave your answer like this, I'll mark you wrong. This is the vector. So therefore, this implies that the coordinate of B is -9, -. Remember I told you, always the object and the image are written in coordinate form. So through this formula, you're able to calculate anything. They can give you the translation and the image. They want to find the object. You can still come up with the answers. What is important is to know the one which is being mapped is the object, onto is the image. So case number 3. So case number 3 is now how to describe translation. That's the case. That is case number 3. How to describe translation. In the exam, when you plot triangles or rectangles or any shapes on the graph paper, how are you able to tell that this is translation? Mostly with translation, there are properties that you must know. Once these properties are known, automatically you can describe any translation. Number 1, whenever whenever all corresponding sides of object and image are parallel to each other, then translation is taking place. So if you discover that the corresponding sides of the object and the image are parallel, it means translation is taking place. That's why so you can just describe through the eyes. You observe lines are parallel to a corresponding side of object and image, and that is translation. Now, don't just say it's a translation, that's one mark, but also they will ask you the vector. So, number 2, state the vector or state the translation matrix. These two things are important whenever you are describing translation. You must tell them the name, it is translation. You must also tell them the vector that was marked in that translation. Then you have described fully. So example number 1, and then we'll be done. Example 1 on description. So this is the x or y plane. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. We've got this triangle here. This is triangle A. Okay. And then we have this one here, which is this is triangle B, and then they'll ask you a question to say, describe fully the single transformation, mapping triangle A onto triangle B. So they will just give you that in the exam, and then they say describe a single transformation mapping triangle A onto triangle B. So first of all, when you are describing, you have to ask yourself the question, am I dealing with isometrics or obliques? Looking at A and B, they look the same. So it means there was no change in shape and size after transformation. It means I'm dealing with the isometric transformation. Now look at what I say. Describe fully the single transformation mapping triangle A. Mapping, so the one being mapped is A, so this one is the object, onto B, this one is the image. So you know that these are isometrics. The first step you have to ask yourself a question. Is this translation? Always start with that. Is this translation? How do you know that it's translation? I said all the corresponding side of the object and the image must be parallel to each other. For example, you take your ruler, you join this line. This line, which is the object, corresponds to this. They are parallel. Take again this one. This line here corresponds to this. They are also parallel. Look at this one. This also line corresponds to that line. They are also parallel. So it means that is translation. So you say solution, you say transformation, mapping triangle A onto triangle B is translation. Just the name, it's one mark. So now, remember I told you, you must also tell them what matrix was mapping A onto B. So you know how to find the matrix. Just do it somewhere. Translation is image minus object. I gave it from the beginning. So if you take this point as your object, take that as an image, corresponding point. If you take that as your object, take that as an image. If you take that as your object, take that as your image. You still get the same matrix. So my image, I take this one, which is 1, -3, 1, -3, minus, that's my image. It means my object should be corresponding, which is 1, 1. So this gives me 0, -4. So you tell them the transformation mapping A onto B is a translation whose vector is 0, -4. It means you have scored that equation without problem. Last example. So this is how we describe translation. So this is how it's supposed to be. Name 1 mark, vector 1 mark. Make the description complete 2 marks. Example 2. Triangle A has vertices 1, 2, 2, 2, and 2, 4. Given that triangle A is mapped onto triangle B by a translation matrix, -2, -1. You say plot triangle B. Plot triangle B. So follow me carefully on that question. Look at what they're saying, guys. Triangle A has vertices 1, 2, 2, 2, and 2, 3. That's triangle A. And then they say, given that triangle A is mapped, so triangle A is the object because it is being mapped. So triangle A is my object. It's being mapped onto triangle B. So triangle B is my image, I don't know. Right? And the translation that we are using to map triangle A, translation matrix, was that one. So plot triangle B. You cannot plot triangle B if you haven't solved its coordinates. So solve it first. B is the image. You know the formula? Image equals to translation matrix plus object. So the image, which is triangle B, equals to now the translation -2, 1 plus the object. You write them as they are. 1, 2, 2, 2, 2, 4. That is the object. Then -2 plus 1, -1, -2 plus 2, 0, -2 plus 2, 0, 1 plus 1, 3, 1 plus 1, 3, 1 plus 4, 5. So it means triangle B has vertices, -1, 3, 0, 3, and 0, 5. It's now these vertices you plot on the graph. So this is how I do it. When I have those now, it will be easy to plot in the graph. So you look at the highest value in the y is 5. All right. No problem. Then the highest value in the y in the object was 4. So already I know what to do. So it means this is the x or y plane. So this is 1, 2, 3, 4, 5. That's the highest. The highest also in the positive x is 2. So I'll say 1, 2, 3 is okay. Then also 1, 2, 3 negatives. Also in 1, 2, 3 negatives. So let me first plot for A. Triangle A was 1, 2, 1, 2 there, and 2, 2 there, and 2, 4 there. So this was triangle A. Then now triangle B, you can plot it also. Negative 1, 3, negative 1, 3 is there. Also 0, 3, it's there. It's 0, 0, it's here, so 0, 3 it's there. And then 0, 5, which is there. So if you join this, that is the matrix, that is triangle B. So if you check indeed, this is a pure translation, because this line corresponds to that line, they are parallel. This line corresponds to that line, they are parallel. This line corresponds to that line, they are parallel. So you have plot on the graph and you score the marks. So last one more example, then we are done. If you got anything, the next example. Patete. Noise irengiro. Patete. 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 Turesanga noise irengiro. Okay, so this is our last example from the extract of an exam paper. It has been drawn, as you can see. There is triangle A, there's triangle C, there's triangle E, there's triangle D, and this is triangle B. And now they're saying, in the diagram A, find the translation. So here they just want you to find the translation matrix, which maps, number one, which maps triangle A onto B. They have already told you it's a translation, so there's no need to test. So this is object, that is image. You know the formula of translation. It's image minus object. So if you decide to pick this as your object, then the image should be the corresponding point. If you decide this as your object, the image should be the corresponding point. If you decide this, any point you try, you still get the same translation matrix. So it's up to you where you feel you are easy to take. Okay, I'll take this one as an object. The image is this one, which is 4,6. 4,6. So 4,6. My object is 1, -1. So the translation will be 4 minus 1, 3. 6 minus -1. So negative give plus will become 7. So this is the translation vector they wanted. To prove my point, what I'm talking about, I can try it here. Just to emphasize. If I picked this as my object, 2, -3, and my image was supposed to be 3,4. 3,4. 3,4. And 3,4, and that one is right. This is 3, this is 7. Okay, that's fine. 2. Number 2, the matrix which maps triangle B onto C. Triangle B onto C. So same formula, translation equals to image minus object. What is the image? It's B onto C. So B is the object, C is the image. So if I take here 3,0 here as my image, minus, this is my image, my object should be that one, is 3,4. 3 minus 3, 0, 0 minus 4, -4. So that's the translation matrix. Number 3, which maps triangle D onto triangle B. So D is the object, B is the image. So D is the object, B is the image. So if I pick this as my image, 3,4, same formula, 3,4 as my image, object is D, so I'll take corresponding to 3 there. 3, 4. Or here it's supposed to be -3, sorry. So it's supposed to be -3. -3. negative 3. Here it's negative side, so negative 3, 0. Here, sorry, so negative 3, 0, even that one was supposed to be negative 6. So here it's negative 3, 0. That's correct on that one. Also this one here, so it's the same thing, negative 3. We are on B, negative 3, 4. And on D, it is the object 3, 4. So this one will give us negative 6, 4 minus 4 will be 0. So that is the translation matrix. Then we go on number B. Number B, they are saying, describe fully the single transformation that maps D onto B. D onto B. So you can see these and this, they are parallel, that and that, they are parallel. This and this, they are parallel, and the size and the shape is the same. So that is translation. So you tell them it is a translation number. That's one mark. Then you say by vector or whose vector. By vector, you've already calculated how which maps D onto B to be negative 6, 0. There you go. So it is a translation by vector. So vector 1 mark, the name 1 mark. Now the last question, which is C. They are saying a translation represented by the column vector. They have given this is the column vector with that translation. It was mapping triangle C onto E. So triangle C was the object, onto E was the image. Now they are saying draw and label each symbol. So meaning find the image. Image is translation plus object. So triangle E, that is the image. Translation that was mapping was this one. Plus the object was triangle C. Triangle C, the coordinates are these. You can start with any order. 0, 2. So 0, 2. Negative 1, 2. And negative 1, 4. Then you deal with those. So after you deal with those, they are going to give you the coordinates of, they will give you the coordinates of triangle E. So you can conclude by saying triangle E equals to 3 plus 0 is 3. 3 plus negative 1 is 2. 3 plus negative 1 is 2. 2 plus 2 is 4. 2 plus 2 is 4. And 2 plus 4 is 6. So it means triangle E had vertices 3, 4, 2, 4, and 2, 6. It's now this you plot on the graph. So E can be plotted as 3, 4, 3, 4. So 3, 4 is somewhere here because that's 4. And 2, 4, 2, 4, it's somewhere there, somewhere here. And then 2, 6, which is somewhere there. So if you join, that's where triangle E was supposed to be. And then you are done. So this is how you do in the exam. So next time we are meeting, we are going to have reflection and notation. In case you've got any question or you want us to respond to any question that you have failed to answer, you can contact the following number 0